What's up, yo? What total axial angular momentum will be for life-hosting stars? Total axial angular momentum is total mass and spin energy of the star. So if the star isn't spinning at all, there's no life. If it spins with very little energy, probably it's very, very small and just the core of an ancient dead star like Mercury, and there's no life there. Venus's axial angular momentum is far lower than the Earth. Mars is too. And I made a quick paper here, April 8th, 2020, but I think it's worth going over because our telescopes and ways of measuring the stars are getting much more advanced. That being said, in order to predict where the life is, if we can do this, we need to measure the total axial angular momentum of the very old star. And I have here, it's going to be the Williams number, which is the total axial angular momentum uh, in terms of kilograms per meter squared per second, with 31 zeros removed. So it's a huge number, but 31 zeros removed, that would be the Williams number. And I have a paper here. I'll only get to the bottom. I won't forget, I promise. At 1,000 Williams, life was exploring land for the first time on Earth. At 10,000 Williams, eukaryotic cells were forming on the Earth. At 100,000 Williams, the oldest fossils of single-celled organisms were found. And at 1 million Williams, the best guess for the beginning of life on Earth is hypothesized. So what we're looking for is if the star falls below 300 Williams, the life will begin dying off, meaning that the star will stop spinning, and a lot of the processes that the star needs to maintain life, circulation of the atmosphere, the heat being recycled through, it being young enough, all lines up to bare minimum 300 Williams. If it goes below that, then the life will begin dying off. Mars is at 20. That's obvious. And other stars, well, obviously Mars, Venus, and Mercury are really, really old. And it needs to be above a certain Williams number, which is above 1 million Williams. Above 1 million Williams. That's funny saying. Hi, Celeste. Above 1 million Williams, the star is too energetic. It's spinning too fast. The atmosphere is probably too turbulent. Things like Jupiter, Neptune, Uranus. That's where the axial angular momentum is just too high. But then again, we don't know for sure. We have to send probes there. But this is a hypothesis, and I'm sticking to it. And another big reason why I did this is when we start finding exoplanets, which are older stars, if we can find out the axial angular momentum, we can figure out if life is on them. And that's essential for scientifically showing where we should look for life, where we should point our telescopes. If we find any information about these objects, we should have a theory that encompasses all the physical characteristics, not just the host star's characteristics, which is what astronomy currently does. They base all the orbiting objects around the host star as being dependent upon the host star, but that's not true. The objects orbiting the host star are independent, and they all came from somewhere else, and their orbital arrangements are temporary, even though they're on very long scales, and they're stable at the moment. All in all, I don't see anybody else talking about this, so I decided it's a good idea to bring up. I hope everybody has a good day and a good weekend. There you go.